I think we've got, looks like we got 11 people now that are all waiting to see what's happening here. With bated breath, you came to see what information security would happen today. And so I will not disappoint you. We got some cool stuff. We're going to do some encryption. And before I get to show you the demonstration, I'm going to do some coding at the command prompt. I'm going to give you some terminologies. The subject today is going to be the idea of public and private key encryption. So I've narrowed down the scope of the audience. If I were to announce this at a friend's party and say, I'd like to talk to you about public and private key encryption, I think I'd probably lose all the people in my little group. So I'm glad you're here because you're a captive audience. You have to watch because I'm the teacher. Hopefully it's relevant to what you're going to learn in your grade. All right, so as I showed you in previous videos and things, we were looking at Caesar ciphers, AES, and hashing. And today we're going to back up to number 3, which is about public and private keys. So this is a really critical, important part of how the internet works. I think I showed you a few of these slides before, so I'm going to go through somewhat rapidly. So the idea of a public and private key is a decoding and encoding process where you have one process to encrypt a document and a different process and a different password to unlock the document. So the analogy is that we have two different kinds of locks. We have a lock that can be closed using a key, a red key, let's say, and then the blue key is designed to open the lock. So that means that the process of the algorithm is different, not necessarily a physical key, obviously. So I brought, I don't know if this is Dumbledore or Gandalf, but this is a real guy. His name is Whitfield Diffie. And his paper in 1976 was called New Directions in Cryptography. What a cool title. It was so understated. And we can say this is the most significant advancement in cryptography in the science of encryption in 3,000 years. And so there he is, standing right in front of you, the man. He wrote a math algorithm that is used today. So if you log into a website that has HTTPS in the title, that you have an encrypted channel, this is the guy that did it. This is the guy that invented that process. So it's just amazing how these brilliant people that have touched everyday life are so unknown. So now you got a guy that you can remember. Here's another guy, Phil Zimmerman. So back in 1991, he invented an algorithm or a public program. That's what we're going to use today. We're going to actually use his software. He invented this software called PGP, and it was just a funny name. Pretty good privacy. And it's more than just pretty good. It's like unbreakable. And the reason why it is so strong, it is so strong, and that is a reason why the US government actually forbade him from sharing it as an export. They considered it a national security risk. And you can get it for free. It's a public domain piece of software. It integrates with lots of different programs. And we're going to use the most basic version of it, the command line, and we're going to try it out. That's going to be part of our assignment. So let's back up a second. So instead of doing public and private keys, let's talk about what regular encryption is. So symmetric encryption, this is the official term for it. So if you wanted to lock up a document, you'd put the key in and then you'd use the same key to unlock it. So it's the standard way of thinking about encryption. You got to have the password. So it's everyone that has the password can get into it. So the problem is when you try to share your key, that's where the issues come in. So if you have a car with shared among your family members, then every one of you has a key, right? You have the same key. You can make a copy of the key. But think of like if you had a keypad on your car. Some fancy cars might do that, where it accepts your fingerprint or accepts a special code that only you know. That would be a little bit more like the public and private key. But in the old-fashioned way, we all share the same key. But what would happen if you decided you needed to share a document with somebody and you had to share the key with them? How do you do that? How do you share a key securely. So if you had to send a key to somebody, you could, like in this case, you could meet them in a gas station, hand them the key. Well, you say that's not going to work. I don't really want to drive, especially if I'm trying to share with a document with somebody in Japan. So here's the other option. We can send them a note. We can put the key in the mail. And of course, you can imagine that sometimes it arrives and sometimes it doesn't. And there's the potential that somebody could steal the key. So that's a security risk. So you could send it in the mail, but I don't like that idea. Or here's the other idea. We could just make lots of keys and leave them around. And pretty much then you have no security, because as soon as you have lots of keys, you have lots of potential. So enter the new solution. So here's what we're going to do to fix the problem. We're going to invent this system called asymmetric encryption. So imagine a lock where not all the keys are the same. A public key can be used to close the lock, and the private key can be used to open it. And here's where we're going to start. We're going to I'm going to show you the process here, and then we're going to get into the terminal and do these things. So we are going to actually type at the terminal some commands here, like GPG. GPG is the new license. You know, new is GNU. The new license for pretty good privacy. So instead of PGP for the command, it's going to be GPG. Confusing, I know, but that's the command. And this is going to be the command to generate a key. And you can see that we have different ways to create the encryption algorithm. Down below, you can see we can use RSA, DSA. Those are different ways to do it. When you generate a key, you're going to get this big, long string of text. Then you can share it with other people. So you can put it online, you can send it by email, you can put it on a billboard, you can do anything you want because it's considered public. Then if I want to send a message to you, I have to specifically mention you when I encrypt it. So here's the command to encrypt a message. I type in the GPG command, the encrypt option, and then R, which is, I forget what R is, but it's going to specify then my destination. My destination is Bill Gates. I want to send an email to the CEO of Microsoft. So I put in bill.gates@microsoft.com. Then the word message.txt is the text file. And then the arrow that goes to the right is to export the output into another text file. So this is what locking a encrypted document looks like when you use a public key. Okay, let's keep going. That's going to generate this message that I can copy and paste into an email. And so that message there is my encrypted file. Okay, yeah, you can attach it. You can send it by other means. You can put it on the web page. So now here's the private key. So now Bill Gates gets this message, and he is going to type in GPG-D, which stands for decrypt. And then he puts in the message name. And since he's already been logged in, it will decrypt his message. So it's using pre-generated keys for both the private and the public. Okay, so let's get into and see what an example of see how this works. I'm going to minimize and show you that I have a couple things open. So right here is a terminal. I'm using a MacBook. So when you use a MacBook, you type in ls. It's like Linux. If you want to do present working directory, it tells you what folder you're in, and I can clear the folder. So you're going to need to have some access to this program called GPG. A couple of ways to do it is, one is to have a Linux machine, which you can do virtually, or you have a MacBook like you have here. And I've been told that on Windows, you can run the Linux prompt or Linux command prompt in an emulator window. Okay, so I just want three things to be able to be seen. So first of all, I have a folder that I titled as encryption, and I have my diabolical plan. And here is the text file. You can see that it's not a Word document, it's just plain text. That's the easiest to work with. So this is obviously secure information. I don't want anyone to see this. So my plan is steal the key, empty the safe, kill the boss, and hide the evidence. And hopefully that works, and I will be able to get away with the crime. So I'm going to go to the document where we're doing the assignment. So I'm going to this first part here that says how to encrypt a default message or a message with default settings. So let me demonstrate. It says here, if you have GPG installed, you should be able to use it at your command prompt. So I'm going to type it out, GPG, and then H is the help command. So I scroll back up a ways, you can see that it tells me all of the different features. So -S or ~sign, -B, ~detach sign. How about this one? We'll probably use this one. -E is for encrypt. Symmetric encryption is -C. Decrypting is -D. So you can type either one of these functions, either a single dash with a D or a double dash with decrypt. So I'm going to try this first one here that says we're going to use symmetric encryption. So let's go back to my bottom here. I got a better idea. I'm going to keep that in one side, and I'm going to make a new window so you can see both of them. Okay, that's pretty small. Bring it up large. Okay, so what directory am I in now? I'm in the wrong directory. So I want to switch to the folder that's on my desktop. So I'm going to type CD and then drag in the folder and press enter. Got it. Okay, so on the right side is my terminal that I'm going to use, and on the left side I'm just going to show the commands. So let's do ls so I can see what my listing is in my directory. So I have a file called my diabolical plan. I want to encrypt it. So let's type GPG, and then I'm going to use this command over here, which is a -C, which is going to use symmetric encryption. And then I'm going to type my file name. So I type in my, and then I can use the tab key, and it fills in the rest of the file name for me. Let's see what it does. I'm going to press enter. It says here, you must enter a passphrase. So this is what symmetric encryption is. We are going to save our password here. So let's type in 1, 2, 3, 4, 5. How about? I can remember that. And do it again. Okay, so now I should see another file over here. Look at there. So I have two files. You can see the original, and then the second one has an extension on it called GPG. Just for curiosity's sake, I wonder what that looks like. So I'm going to try to open it. And it says here I can use text edit as a file. And there it is. Isn't that interesting? So I now have a completely encrypted mess. There's no way I'm ever going to read that. So now let's pretend that I delete this original document. So I'm just going to drag it to my desktop so it's no longer in the same folder. And the only thing I have left is the file that's not deleted. So let's do an decryption then. So I type in GPG, a decrypt, and then the file name, and press enter. Okay, and it shows it on the screen. You can see the contents. I'm going to try it again. I'm going to use the up arrow, and this time I'm going to say this is the output txt file. So I am redirecting the output to a text file. And let's go check it out. So I have output txt. I'm going to open that. And this time I'm going to choose a different text editor. I'm going to use Sublime Text. That's what I use for web development sometimes. And there's the original, and now here is the unencrypted one. So you can see that I successfully did a symmetric encryption. It went to an encrypted state and then to a decrypted state. Now, I can also have a problem because if I want to send this by email, I need to put it in a text format that an email editor can see. So GPG is a format for what's called binary text. I'm going to go back and look here at another option. I think it's called A for armor. So armor, I have no idea why they came up with that name. It's doesn't make any sense to me, but I know what it does. It says create ASCII armored output. And the best way to describe it is just to show it. So I'm going to use the encryption again. And this time, instead of just C, I'm going to put in another one. I'm going to put an A. So C and A. Oh, I can't do that. I have to put in two different formats, like there, C and A. Oh, I don't have that file. I have to put it back. Pardon me. It doesn't exist here, so let's put it back into its original location. There we go. Now I'll try it again. Perfect. Okay, so now this time it says I'm going to need another password, so I'll use the same password, 1, 2, 3, 4, 5. And let's see what came out this time. So I added the -A option on this guy, and over in the output, you can see I have a new file. It's called ASCII as the extension. Now I'm going to open it with the text edit, and we should see something a little different. Let's put them side by side. So the first one that we did was in binary format. And that is not very suitable for sending in an email message. It's got all these strange characters, and they may not get formatted correctly. However, this other format called Armor is just as secure, but it has a smaller set of letters that it uses. So all of these letters here are in the ASCII range. So ASCII is the American character something information interchange. It's the set of numbers and letters that are used on all computers today. So it's in more what we would call plain text, readable text to a text editor. So now if I wanted to send this, I would copy here, and then I would take this message, paste it into Outlook or Gmail or whatever I'm using, and send that off to the other end. And the other person would be able to do the same process. They could copy this, put it into a text file, and then run it through a decryption. So that's the process of symmetric and encryption and decryption. So in your assignment down here, I'm going to bring this up here. What I'm going to ask you to do is pretty much the same thing. So I've got the steps listed out in case you didn't catch them, everything that I was showing you. But we're going to take a message file, encrypt it, and you can see the two file extensions are different depending on the option you use. And then you're going to decrypt it. Okay, so there's some commands to use to make this happen. And there's the decrypting process going on. Now it says here, I'd also like you to check with this says verify that the file has not changed with a hash. So if I look at my two files, those were the encrypted messages. Don't know if that's the actual, if they did it the same way or not. So I have two different files. I have my diabolical plan, that was the original, and then the output. I'm going to check to see if they've been actually corrupted. So the way to do that is I use this thing called MD5 sum. So let's see if that works. MD5 sum. If I press enter, oh crap, it doesn't work on my computer. I don't have that installed. MD5. MD5 does work. Okay, so let's do this one. Let's try MD5. Now I'm going to put in the file name. So it was my diabolical plan. And there is my hash value on that document. Now let's see. If I want to verify that the output is the same as the input, I can type in MD5, and then this time I'm using the word output. And what do you think? Is one significantly different than the other? Are they identical? If I look here, This one starts with a hash value of 4F36. And this one here is also 4F36. And if I wanted to compare letter by letter, I would see that yes, they are identical. So the last few letters are C9F3, and those last ones are C9F3 as well. So I have proved through hashing that there has been no tampering. The encryption process and the decryption process did not corrupt the document. So there you go. I just proved that. Okay, let's move to the next part. So the synchronous encryption is straightforward. The asynchronous is a little bit different. Let's see how that works. So it says the first step is, if you're going to do this, you have to create your own private and public keys. So let's see how that works. So I come into my command prompt again, and I'm going to follow the instructions as they're listed here so I don't forget, because I don't do this every day. So the first step, it says you have to generate a key. So let's try this, GPG -- gen key. And it says, now, how do you want to design this? What kind of key do you want? So I'm just going to press 1 for RSA. Now it says, how long do you want your key size? And they provide 2048 as a default. That's fine. How long should this key be valid? So I'm going to keep mine for 5 years. And it expires in 2025. How about that? Who knows what we'll be doing in 2025? Is this correct? I'll tell you yes. Okay, now I need a name. So my real name is Shad. Oh, I have to have at least 5 letters. Let's try that again. Let's try Shad Sluter then. My email address, I'm going to do shad.sluter@gmail. No, what is this? Where do I work? GCU. The comment. I don't know what I'm supposed to say for the comment. I'm just going to say, hide my info. All right. Is this okay? I'll type an O for okay. Now I need a password for my secret key. All right, here's my secret key. Believe it or not, it's 1, 2, 3, 4, 5. Now that you all know my secret key, it's useless now. And it says, you haven't entered an insecure password. It should be 8. Okay, well, I'm going to use it anyway because I don't care about the security here. Let's try it again. 1, 2, 3, 4, 5. There we go. So it says you now have a key. Let's see what it's got listed down here. I have a public key, and it gives me a fingerprint, a UID, and a bunch of other stuff. Let's go down and see what we're supposed to do now. So now if I want to share my public key, I'm going to use this next command, which is this, GPG, and I'm going to use the export command. And I put it in the armor. Let's see, is it armor? Armor. And then my email address, I think I'm typing the armor wrong, but we'll find out. GCU edu. And then I'm going to put the output file to Shad Sluter GCU pub key. And let's put in ASCII for an extension. Yeah, I didn't like the word armor. I think it's more the British way to spell it. AMOUR. Still doesn't work. How do I spell armor? AMOR. AR. Oh, armor. Got it. Okay, so now I have just created this key. Let's go take a look in my folder and see what has just been done. So there is a public key. So now I'm going to open that up and see what in the world just was created. So this long key here is what I would share with you. I would publish this on my website or somewhere where you can get it. And now this is going to be the way I encrypt data. Now that's just half the process. So let's keep going to the next part. Now, let's say I have another person that sent me their public key. So this is the process to take it into my system here. So let's see, where's my terminal? There it is. So I don't think this is going to work because I am the person that sent it. But anyway, I'm going to type in this and import it. It says you can't really import it because you've already got it. Okay, but if you were to, what I want you to do on this assignment is to actually share your key with another student, and then you're going to import their key. So I'm trying to import my own key. Let's see what's in my list now. GPG, list keys. So who's in my list? Okay, it looks like I've got about maybe 3 or 4. So here was one of them. So I just did this one today, October 1st. I did a key way back in 2017. Okay, so I've been using this for a little while. And it was the same key, except this one is now expired. And here was another. This is my Gmail address. So I sent one to myself. Okay, so I do have another account. I could use my Gmail address and my GCU address is 2 different people. Okay, so now let's say I want to send something. I'm going to send a message to, instead of Bill Gates, I'm going to send it to my Gmail address. So that's the gmail.com. And I want to encrypt the same diabolical plan. So let's try this command here, GPG. I'm going to do encrypt. And then you have to tell it who you're sending it to. So the recipient. And then the, am I doing this right here? Armor. And then I'm going to send in my shadsluter@gmail. And then the file name, which is my diabolical plan. And I reversed it. So that makes sense. I need to move this. Recipient should show the email address immediately following. And probably put armor in like there. Okay, so now it says I'm ready to encrypt this data, and you've already got one called my diabolical plan.asci. So I'm gonna overwrite that one because don't need it anymore. Now let's go look at the diabolical plan, see what came up here. So this is the one that I just created a second ago. I'm gonna open it up. And it looks a lot like the last one. I'm going to close some stuff here and try again. Open it. There it is. This is the one. So now I'm going to email this thing off to shadsluter@gmail.com. And it is only able to be opened by that one person. Let me show you why that works. So if I want to decrypt a message, I'm going to have to know what my private key is. So let's see if this will work. I'm going to say GPG decrypt, and then my diabolical plan.asci, right? And then let's see what happens. It says now you need a passphrase to unlock the secret key for shadsluter@gmail.com. So you notice it says you can't use your private key for the GCU email. And honestly, I have no idea what my password is anymore because it was 2017 when I created this private key. So is it password? Is it 1, 2, 3, 4, 5? I have no idea. I'm going to just put in the word 1, 2, 3, 4, 5 and see what it does. No, wrong one. Let's try password. Also the wrong one. I don't really have any idea what it was. And it says you failed. You have failed me for the last time, and it quit. Okay, so my experiment and my demonstration fails here because I don't remember my password that I created 3 years ago. However, if you actually had a private key, you would be able to unlock it. So this demonstration is to show you that you can send encoded messages by email using this GPG tool. Now, what we're doing today is all command line prompts, and you have to copy and paste and put it into your email client. There are more convenient ways to do this. There are email clients that are built right integrated with GPG, so you can get a different version of Outlook or something, and you don't have to worry about copying and pasting so many things. But when I'm done, I will have an actual decrypted message. So I got right up to the finish line and then failed. I tripped before I crossed the tape. Too bad.